Good day, students. Welcome to part 3 of our differentiation flashcards review. We are going to be going over formulas 8 through 13. We're going to be focusing on trigonometric functions and their derivatives. Don't forget to visit mathgoodserve.com for access to the remainder of the differentiation flashcards. Right, so formula 8, the derivative of sine u, d dx of sine u, the derivative of sine u is cosine u du dx. Now you might wonder what is the u and the du dx. Well, this is a representation of the chain rule process. U represents a composite function. You notice x and u are different. So when you're differentiating a composite function, you differentiate the outermost function first, holding the inner function fixed, and then you differentiate the innermost function, the inner function. So the du dx you see here is a derivative of the inner function. So you're going to be seeing this du dx in all the formulas I'll be showing you from 8 to 13. Let's take a look at an example. The derivative of sine x is cosine x. The du dx in this case is dx dx, so that is basically, that cancels out, it's just 1. So this is not a composite function, so this du dx piece is basically dx dx, and that drops off. Next formula. d dx of cosine u, you read it as the derivative of cosine u. The derivative of cosine u is negative sine u du dx. Take a look at an example. The derivative of cosine x squared. Now in this case, u is x squared. You can see the composition of two functions. The cosine function is the outermost function, and you have the square function as the inner function. So the derivative of that, you differentiate the outermost function cosine first to yield negative sine, leaving x squared fixed, times the derivative of the inner function u, which is x squared. And if we apply the power rule that we learned in part 1 of this flashcard series, remember the power rule, the derivative of x squared is going to be 2x raised to the first power, which is just 2x. So negative sine x, negative sine of x squared is a derivative, negative 2x sine of x squared is a derivative of cosine x squared. So that's an example. d dx of tan u is read the derivative of tan, or you can call it tangent u. The derivative of tangent u is secant square u du dx. Let's consider an example. The derivative of tan x is secant square x. Remember, this is not a composite function, so we do not need to multiply it by a derivative here. We have dx dx, which cancels out to just 1. d dx of cot u, you can read it as the derivative of cotangent u. The derivative of cotangent u is negative secant cosecant square u du dx. All right, negative cosecant square u du dx. Now an example of this is illustrated below. Let's take a look at it for a minute. So we have d dx of cotangent u. U in this case is sine x. So if we are applying the chain rule to this composite function here, we're going to differentiate cotangent first, holding the u function fixed. What is the derivative of cotangent according to this formula is negative cosecant square u. U is sine x. You leave the innermost function untouched. Okay? And then you multiply your result negative cosecant square u, where u is sine x, by the derivative of what u is. U is sine x, and if we apply one of the formulas, the trigonometric differentiation formula we just went over in this series, we know that the derivative of sine x is cosine x. So if you rewrite it, the derivative of cotangent of sine x will simply be negative cosine x cosecant square sine x. All right, moving right along. The derivative of secant u, d dx of secant u, the derivative of secant u is secant u tan u du dx. That's applying the chain rule here again. So the derivative of secant u is secant u tan u du dx. An example, what is the derivative of secant 3x to the fourth power? The derivative of secant 3x to the fourth power, we're going to apply the chain rule here. U in this case is 3x to the fourth. So we have secant u tan u. So u is 3x to the fourth and 3x to the fourth. So that's secant u tan u times du dx, as illustrated in this formula. So du dx is the derivative of u. So if we apply the power rule to differentiating 3x to the fourth, we're going to have 4 times 3, which is 12x to the third power. And if we rewrite it, our answer will be 12x to the third, secant 3x to the fourth, tan 3x to the fourth. So that's an example illustrating the use of the secant differentiation rule. Let's take a look at the next one. d dx of cosecant u. It's read the derivative of cosecant u. The derivative of cosecant u is negative cosecant u cotangent u du dx, where du dx is the a consequence of applying the chain rule in the differentiation of u. So let's take a look at an example. What is the derivative of cosecant of secant of 3x? So we have three functions here being composed with each other. The outermost function is cosecant, followed by secant, and then we have the linear function 3x. So if you want to differentiate this, we're going to start from the outermost function and work our way in. All right? So let's go ahead and show you what the answer is. Starting from the outermost function, if you're differentiating the outermost function, the inner functions stay the same. We'll call them u. So the derivative of cosecant u, considering secant 3x as u, we have negative cosecant u cotangent u, as illustrated here. Okay, so this piece clearly shows the application of the differentiation rule for cosecant. After you're done with the outermost function, you're going to go to the second to the innermost function, which is secant. We're going to differentiate that, holding the innermost function 3x fixed. So now we're going to make use of the differentiation rules for secant. Do you remember what that is? The derivative of secant u is secant u tan u du dx. So in this case, u is 3x, so we have secant u right here, tan u, and we'll finally multiply it by the derivative of the innermost function, which is 3x. The derivative of 3x is 3. So this expression right here is the derivative of cosecant of secant of 3x. Okay, so we're applying three rules basically in determining the value of the derivative of this expression. So that's that. Thanks so much for taking the time to watch this presentation. Please subscribe to our channel for updates to the remaining of the differentiation flashcards. Remember that you can basically use this tutorial to create your collection of flashcards. And then just study it over and over again until you have all the differentiation formulas memorized. Do feel free to post a comment to let us know what you think about this clip. We really appreciate it. And do give us a thumbs up if you liked it, and do share it with your friends. More clips can be found on modulserve.com under AP Calculus. Thanks again for watching, and have a wonderful day.